Right, well, what I want to try and do here is to give you a talk through of some of the common errors and misconceptions that I was encountering while I was marking this paper back in November. And as I go through it, I might refer to particular aspects of the mark scheme and also comment on other misconceptions that haven't been written in this paper. So if we start with question 1, which was a distance time graph, what I've done is where the answers are in dark blue, that's actually correct because there's nothing really I can talk about there because I can't tell whether kids who've got it wrong have just guessed. So there's no misconceptions that I can comment on. Where the ink is in light blue, that is somewhere where I'm highlighting a misconception. So with this first question, the misconceptions tended to be about the fact that when kids have been taught about a distance time graph, they almost always think that part of the distance time graph that is horizontal will be where the person is stationary. So this is straight away challenging the way that they commonly think about a distance time graph. Where you've got higher tier kids or more able kids being entered for this intermediate paper, they are confusing it with a velocity time graph, where a horizontal part of a velocity time graph would mean that they're not accelerating and they're travelling at a constant speed. So quite able kids were making that first bullet point mistake there, where they were saying he's travelling at a constant speed. The other sort of mistakes then that kids were making was to say that they were travelling on a straight road or a flat road. I think if they'd have commented that the road was parallel to Gareth's home, then they'd have got the mark for that, but didn't see very many, if any, uses of the word parallel. And another common mistake was to actually insist that he did stop and that the question is wrong, or that they chose to miss out that statement within the question that Gareth was not stationary. So lots of students who got it wrong were actually insistent that he did stop. So just to give that a mark there, that particular question, that question would have got 1, 2, 3 out of 4. There'd have been no mark for the explanation. Then we come to the pie chart, and I would say certainly majority of kids were getting full marks on this particular question. It was one that was accessible across the ability range. We were looking within the mark scheme to see those numbers there, to see that the kids had accurately measured those angles, and if they had, then straight away they were going to get 2 out of these 6 marks that are available. This particular student has recognised that a quarter of the total is for talent shows, so a quarter of the 3,600, and lots of students were correctly working that out as 9,000. And then lots of different things were taking place. In order to come over to drama, some kids were working out there was an extra 10 degrees on that, working out what 10 degrees was and getting in a mess with that. But quite a few kids were then confusing degrees with numbers of people. So that was a fairly common error that you would see there with the 9,000 and then adding 100 rather than working out how many people that was equivalent to. So that particular part of the question would get 1 mark for the 100 degrees. And then in the second part of the question, what the kids were required to do was to work out what the difference was between the number of people watching sport or taking part in sport and watching news. So lots of students who had correctly measured those angles were then working out that the difference between the angles was 60 degrees. Lots of them would then go on and correctly work out what the actual number is and get full marks. But again, many students were stopping at 60 and going no further than that, so saying that that was 60 people rather than a 60-degree difference. The fact that they correctly measured those angles would, again, as I mentioned earlier, get them the 1 mark for that part of the question. So the next part was where they actually needed the 9,000, and here the most common place where students would go wrong would be in actually recognizing that they need to work with thirds for that particular ratio, twice as many women as men, and it was very common to see them halving and halving again in order to work out those particular ratios. If that is what they did, they got no marks at all. There wasn't any credit at this point for finding the 9,000. Part B was generally well answered. You were more often likely to find the correct answer here than an incorrect answer. But a very common incorrect answer was to start off you trying to use the 1,000 and working out 70% of that, then recognizing, oh, I need to get an angle in here, so I need to use 360 degrees, and getting in a knot from there. So that was fairly common mistake, was to be working with the 1,000 and 70% of that rather than finding 70% of the 360 degrees. So again, there would be no credit for that particular answer at all. Question 3, if I jump quickly to the answer there of 9,800 euros was probably the most common incorrect answer. So the stages that this candidate has gone through was a pretty common incorrect answer. They would earn 1 mark for correctly recognizing that the earnings that will be taxed will be 31 euros. So they get 1 mark for that. Then they would generally go on to work out what 25% of that was, not recognizing they need to take off the tax-free aspect of that. So they would go and work out 25% of 10,500. Now, a common theme came across lots of candidate papers who tended to make mistakes were candidates that were inappropriately using non-calculator methods on a calculator paper. So rather than just using their calculator to find 25% in one go, they wanted to demonstrate that they could find 10%, 5%, and from there work out 25%. Now in this instance, this person has got that actual aspect right, but very, very often, and here with 35%, mistakes would be made that would have unlikely to have been made if they'd have just used a calculator. So this student has incorrectly decided to find 25% of 10,500 instead of 25% of 10,500 less the 3,500. And similarly in this part, the 35%, again, this candidate has worked out 35% of the wrong total amount. But within the mark scheme, it was recognised that it was creditable to find 25% and 35% of those two amounts. So those particular outcomes would each be allowed 1 mark. And then the total tax paid using that incorrect answer and that incorrect answer was follow-throughable. So they would get a 4th mark for that. So that particular incorrect answer would actually earn 4 out of the 6 marks that were available. If there was any other quantities that 25%, 35% was worked out on, apart from the correct ones, then they wouldn't have earned those marks, and without those, they wouldn't have earned the 3rd mark the final mark either. So if they went wrong in this part, they tended to earn 0 or possibly 1 if they'd worked out one of the differences. With question 4, which was in exchange rates, many students got full marks on part A, but a couple of common mistakes was once they'd calculated that and they'd written that down, they would then look at the answer, which had no decimal point in, and decide to insert a decimal point after two decimal places. So in inserting that decimal point, they've ended up with an incorrect answer. Also, if they hadn't put any currency units on their answer, then they would earn full marks. But if they put an incorrect currency, so if they incorrectly put a euro sign or a pound sign on there, then they'd be penalised for that as well. So for this particular student, they would earn 1 out of the 2 because the method is correct. They've just decided to give a 2 decimal place answer. For part B, the students tended to go wrong as often as go right on this part. I probably saw as many completely right answers as completely wrong answers, and there were a number of different ways they would go wrong here. First of all, the students correctly worked out what £450 would buy at that exchange rate, and again units weren't expected here. The common mistake to make would be when rounding to the nearest 500, and you would see them subtracting 500 from it. Or another thing that they would do is then divide the 44874 by 500. So they would do 44874 divided by 500 and get the 89.748 500 rupee notes, but then they would forget that they can't have 89.748 500 rupee notes, and they would then go and work with that complete decimal string rather than rounding it to 89. If they rounded to 89, then they would get further marks for that. So once they've gone wrong here, there's no credit for what they're doing down here. So although now this candidate has decided to divide that by 99.72, which would have been the correct thing to do if that would have been correctly rounded to the nearest 500, they're not going to get the credit for that. So it's only if the nearest 500 is actually a multiple of 500. So for this particular candidate, out of those 4 marks, they're only going to get the 1 mark for calculating that. Question 5 was beyond doubt the most time-consuming question to mark on the paper. Again, it was interesting when looking at the candidates' answers how much of this would be highlighted by various students. I don't think they're particularly well trained in, if they're going to use a highlighter, actually recognizing what the key information is for them to highlight. Most students who didn't get full marks were able to work out that Larry was going to pay 507. Quite often the first mistakes made was actually working out how many trips they needed to make. Quite often they would only make 3 trips, sometimes they would work out the value of 1 trip, but more often than not they were working with a multiple of 6 and they were getting the 507. And what they need to do as well in order to get these OCW marks is to actually explain in each step what is happening. So here this candidate is saying, well, they've gone there and back 3 times, that's where that times 6 has come from. When it comes to Neris, there's a whole can of worms as to the mistakes that candidates were making. But again, a very common mistake was when working with a third, or sometimes 2/3 if they were working out from the other, coming from the other direction, they would want to turn that into a percentage and then go down the 10%, 20%, 30%. So they were, whereas the easiest thing to do here would have been to divide by 3 on a calculator, they were uncomfortable doing that with a fraction, and they wanted to turn it into a decimal, or more likely a percentage. And in doing so, immediately the level of approximation that they were using was too approximate. So they would go from 1/3 to 0.3 to 30%, and then end up with an answer which was quite a long way away from what was acceptable. What this candidate has done is not only incorrectly found a third, but, and this was a very common mistake, once they'd found a third, even if they'd worked it out correctly, they then omitted to subtract that from the cost of the ticket. So they then went into the next part of the question, having found a third, basically saying, or using that as what Neris had paid for the ticket, not what she had saved. If with this particular question the candidate had then subtracted that from the 507, then it would have been possible to get the next part mark, which was for the adding 30. But you could only add 30 if this value, the method for finding it, was correct. So the method for finding it was to actually work out 2/3 of 507. So this candidate is being penalised heavily, once for the fact that they're finding out 0.3 or 30% instead of a third. Then they've omitted to take that away and find the difference, and because of that they forgot to add 30. Now, very common mistake was to correctly work out that aspect but then forget to add on the 30. So this particular candidate isn't going to earn any credit for this body of work here, and because they haven't earned the method marks in this part, they don't earn any credit down here for subtracting that wrong answer. So for this candidate, the only maths marks that they can earn for what they've done is for this first part there, where they've worked out what a Larry has had to pay. The other common mistake that was being made was just to say, and again this was from misunderstanding the question, that Larry is going to pay 507 and Neris is only going to pay £30 for that year. So they would then work out a difference between 507 and £30 to work out what the saving is. And again, a student that did that, even though they've done a lot less work than this one has, only gets the 1 mark for that 507 and no credit for anything else. However, once that is done, then we have the 2 additional marks to award. And if I just show you how those are awarded. The first one is for organisation and communication, and what we're looking to do is, if I can just fit everything on, asking yourself the question, regardless of the maths that they've done, is it presented in a structured way? Well, that is. Are they explaining to the reader what they're doing at each step of the response? Well, they're explaining there that they're finding a third. Yes, they've found a third incorrectly, but I know that that's what they're trying to do, and I know that that's what this candidate then thinks they're going to pay. So they are explaining what they're doing at each stage. The explanations of working is clear and logical. They've clearly separated Larry from Neris and showing each stage. And there is a conclusion that draws together their results. The conclusion is that Neris pays 320 odd quid less than her sister. So this candidate, even though most of the maths is wrong, is going to get that organisation and communication mark. And with regards to the accuracy of the writing, they've shown all their working. There's no errors in spelling, punctuation and grammar. The mathematical form is correct in what they've done. Even though a third isn't 0.3 or 30%, the mathematical form, not the arithmetic, is fine. And the appropriate units and so on have been used with the pounds. So this candidate is actually going to get both of those OCW marks. So they end up earning 3 out of 7 for that question. Okay, 5B was probably one of the poorest answered questions on the paper. This was the most common incorrect way of doing this, where the students would work with the cost of the rail ticket rather than the saving of the rail ticket. So what they needed to do here was to work out what a third of £7.80 was and see how many times that divided into 30 rather than what the £7.80 divided into 30. So this particular answer regularly got 0 marks, as this does. Question 6. More often than not, this was correctly answered, but a common mistake that was being made by lots of students was they were required to work out 24% of the area of woodland in Wales, and the students ended up working with the 2000. So by far the most common error was either finding out 76% of 2000 or 24% of 2000 rather than the 303,000 hectares. And when they were doing that, if that's the total they were working with, then there were no marks available to them. So this particular answer, and again here I'm emphasizing that lots of students wanted to show they could use that non-calculator method for finding out 76%. Nevertheless, 0 marks. Question 6 was generally more often wrong than right, and I think that is down to the fact that probably certainly foundation tier students aren't taught the power method of compound increase or compound decrease, and they were trying to work out a repeated reduction of 2% on 34 over 2 years, and then a repeated increase of 6% over 5 years, and getting in one form of knot or another because of the amount of time and calculations that was required. Where students tended to correctly know how to use the power method, then they were often getting full marks, but there were fewer of those than those that would lay it out in a way that might be appropriate over 2 years or 3 years, but certainly not over a 7-year period. Very often students would only reduce by 2% once, so they missed out the fact that there were 2 years required of reduction. So lots of students would go into the second part of the percentage change with £33.32 and then go on and correctly work with that and earn credit because of that. But for this student, they're going to lose, they're not going to gain any marks because they've only reduced by 2% once, where they need to demonstrate a repeated reduction, and then although they've correctly got the 1.06 as a 6% increase, they worked out the power of 7, not 5, on the £33.32, which on a calculator then produces 4.83 times 10 to the power of 10, which they think, oof, something gone wrong there. That probably means £48.33. So there were lots of places on this question where the students could go wrong, but I think the message that came through in the examiner's conference for this paper was that schools should be encouraged now to teach the weaker students how to use the power method in compound change, because they're likely to be choosing larger numbers in the future that's appropriate to use the 1 year, 1 year, 1 year method. Question 7a, again, you can't really pick common misconceptions with this because the students were able to guess. So I've just circled there the correct answers for those 3 questions. So on this paper, that candidate will get 3 marks. This question was far more frequently answered correctly than incorrectly, but a common incorrect answer was to work out what the difference is between the width and the length in that shape and assume that that difference would be the same in this rectangle. So rather than working out what the scale factor is between the 2.1 and 33.6 and applying it to the 2.6, they would work out that there's a ½ centimetre difference between that length and width, and therefore you would expect there to be a ½ centimetre difference between the width and length on the enlargement. And that particular question, as you would wholly expect as a maths teacher, would get, or that particular answer would get 0 marks. But loads and loads of students got that right. Then we come to this question. Now this question was a Pythag question, and most students that attempted it got it correct. Probably where they tended to lose a mark was if they hadn't correctly rounded to 1 decimal place, or they'd ignored that instruction and given it to more than 1 decimal place. What this candidate has done is actually drawn a scale diagram, and for that reason is not eligible for any marks. Now what we were asked to do, if there were cases where 4.7 was just written down, was to look through the whole paper to check that there was no evidence of any scale drawing anywhere else. To be honest with you, I didn't see any instances where just 4.7 was written down. Candidates weren't often trying to attempt a scale drawing. They were recognizing that Pythag was required and making some creditable effort towards that. The second part of the question again tended to be, if students got the 4.7 there, they tended to get the full marks here. A common mistake though was just to, if we go back here, it says here that the height of the window guard is 9.5 diagonals and 11 diagonals. A very common incorrect response would just be to read those as the length and width of the rectangle and do 9.5 times 11 rather than 9.5 lots of the diagonal multiplied by 11 lots of diagonal. So that was a very common incorrect thing to do. So for this particular example, for this candidate, out of those 6 marks, they would get no credit. Question 9 threw up a number of common mistakes, and they usually revolved around dividing by 7 at some point for the average speed by the week, for the week. Lots of students were working out an average, or attempting an average speed for each day. Sometimes they would be doing that by doing the 4.6 divided by 26, which is what I've done in this example. Sometimes they would correctly change that into hours and do 4.6 divided by that time in hours, but still across each of the 7 days. Sometimes they would not like to divide 4.6 by 26. they would rather do the big number divided by the small number. So they'd be doing the 26 divided by 4.6. So there's all sorts of mistakes available to them, and lots of candidates chose one way incorrectly of doing it or another. Some students were correctly doing the method of adding up each row. The total time comes to 180, and the next mistake they would make would be to divide the total distance by 180 rather than turning the 180 into 3 hours first. So plenty of scope for incorrect work for the 4 marks that were available for working out the average speed for the week. Even when candidates were correctly working out the average speed for the week, far fewer of them were able then to work out the percentage change. So it would suggest that that is something that hasn't really been focused on in preparation for these papers. It wasn't something that they were confident to do, was to work out the difference, divide that by the original amount and turn that into a percentage. So for this particular example, there are no marks available. The way that the candidate has worked out the average speed is per day, and although they have there turned it into kilometers per hour because they've recognized, oh, there's something wrong here, that should be bigger than that, or I'll times it by 60. The method of then dividing by 7 isn't correct. So there are no marks available. If they'd have correctly totally added those up, then there would have been a mark for seeing the 31.2 of the 180. Here they've incorrectly worked this out, so they wouldn't get the marks, or would they? They might get a mark actually. I'm trying to think back now. Because they've turned that there, if they'd have left the answer as 0.17, then their method would have been, no, their method is wrong because they're divided by 7. Yeah, so there's the method is wrong for that, so there's no marks for that, and there's no marks for this part. If they'd have gone on and divided that by 9.6 and times by 100, then they would have got the 2 marks for the percentage change. But because they haven't done that, then they're not going to get the credit for that. So the amount of incorrect work there is unable to pick out any correct marks for that. Part B, where students had a rudimentary knowledge of basic right angle trigonometry, they were tending to get 3 out of 3 there. So this particular question was one where they were likely to get 3 marks or 0 marks. 0 would either be a question which has been totally left out, or they would see 2 sides of a right angle triangle and plough into Pythag again, or they would do 1600 divided by 200. But that particular thing, even though they aren't identifying an angle there, there's enough credit there for them to get the 3 marks. In part C, it was quite often you would see in an incorrect answer further attempt at Pythag. What the students would do is they would pull the 1600 meters down from there, not recognizing that it's a completely different stretch of road, and use that. The trig that they're required to do here ends up with them having to rearrange the formula because the unknown is on the denominator of the fraction. So it was only the more able students that were getting 4 marks here, or there would be 3 marks actually for the maths and then an additional mark for the assumption. In order, even if the statement is correct in this part, they would have had to have put an answer there from a trig piece of maths or a Pythag piece of maths. If they'd have done anything else there and come up with a reasonable assumption, there'd be no credit for it. In this particular example, because the student has attempted to use Pythag, then that assumption is a reasonable assumption. We would accept the word even to mean flat or smooth. So they would get the mark for that. They wouldn't get any mark for the maths. And again, that would be on the limits of what we would say is reasonable as an answer. The fact that our answer is inaccurate, or their answer is inaccurate. One of my favourite wrong answers for that, which I saw quite often, was the impact would be we'd get an extra mark, which made me smile as I was ploughing through. Okay, then we're on to question 10. Mean of group data. And the common errors that you would encounter here would be, and this one I would say is understandable, because I think this is the first time I've seen a group frequency diagram for the mean of group data where all of a sudden the class intervals change. So what the students are doing is they've worked out the first couple and seen that they're going up in 1.5s, so automatically write 6 as the midpoint of the final interval, and it isn't. More often than not, the students would then correctly go on and multiply the midpoint by the frequency and work out a total. For my example, they would lose the mark for the incorrect midpoint, but they would get them correct, keep the mark for working out the sum of the midpoint times frequency. So out of the 2 marks available there, they will get 1. Then we come to the actual calculation, and still very, very common mistake would be to divide by the wrong quantity and not divide by 20. If this candidate had done 81 divided by 20, even though they'd made that mistake there, they would have ended up with 3 out of 4. For this candidate, that is wrong, so they lose the 2 marks available at that part of the calculation. They lose the mark for that, so they end up with 1 out of 4. Second part, which is a ratio question, it was very rare to award 3 marks on this question. 2 marks was quite common, but more often than not it would be 0. And what students were doing is they would recognize that they would need to work out the total number of parts, so 7 plus 8 equals 15 was commonly seen. But then rather than working with all the dust particles, 45, they were working with the first number they saw, which was 25. So the correct thing to have done would have been to do 45 divided by 15, but more commonly, and then divide that into the ratio of 7 to 8, but more commonly they would work with 25 and end up with figures like that. And I've even made a mistake there on my wrong answer. I should have written down there 13, not 33. So that should have been, even as a wrong answer, I was intending that to be 13. So that was a very common mistake to make. The students that went and worked out correctly, dividing the ratio 45 into 7 to 8, and got 21 and 24, those candidates were getting 2 out of 3, because in order to get the final mark, it was how many of the extra 25, so they would have to take from it the 8 dust particles in the first part of the question to get the final answer. This candidate scores no marks. And then the final question, and this tended to, I would imagine, sort the higher tier students who'd been put in at intermediate level to be safe from the foundation tier students that were put into the intermediate tier level because they had nothing to lose. So there were a great number of blank pages that I encountered on this particular part of the question. A common incorrect decision that students were taking was that if the circumference is 5, they would take the radius to be 2.5. In this example, the candidate then goes on and correctly uses the radius of 2.5 to work out the volume, but unless the radius is calculated using the c equals pi d or 2 pi r and ended up being a fraction of pi, there was no credit for that, and if there was no credit for that, nothing could be earned here. So this, no matter what correct maths is there, would earn no marks. It tended to be that that question earned no marks or 5 marks, and by far the more common was 0. So that particular candidate, if we go back through the paper, would have got 1, 2, 3, 6, 9, 12, 14, 18, 20, 23 marks. So that's 23 out of 80. Now, at this stage, we've got no idea what the grade boundaries are going to come out like. So I've got no idea what grade that would be equivalent to. Hopefully that's proven useful to you and given you some idea of the feedback that you can give students in the spring when they get their results back.